In this video, I'm going to show you how to work with G++, GNU compilers, and we also have MSVC compiler suite. Both of them are a complete package, consist of preprocessor, compiler, assembler, and linkers, and we are going to see all of those steps, all of those phases in this video, and see what code they will generate in each step. So I provided some files here, a header file with only a variable called y is equal to 5, a mass file with a function accept two variables, and its definition inside the source file. I'm also going to create another file which is main.cpp that use these header files, these files actually. So let's begin. Main.cpp, and let's take a look at it. So I'm going to include b.h, include mass.h, define a macro called pi equal to 3.14, the main function. I'm going to use that foo function from mass.h, so we can write, define a variable float z is equal to mj foo pi and y. Please note that I intentionally going to make some mistakes. For example, I know that I should use mj.y as the scope, and for printing printf, it's a float, so I need to use f for the flag and z. So I also know that for printf function I need to include stdio, but I'm going to ignore it, but I will add extend int y because it's defined in another translation unit. So just mj dot as the second row to include this printf header. I'm also going to add a comment here called inside main function. Inside main function. This is also intentional. So this is enough. Save it. Let's see what is the first step. We need a .cpp file as the source code, and the first step is preprocessor. I will pronounce it incorrectly. So the task of preprocessor is to include headers, expand macros, and also ignore, or better to say delete, comments. So it will substitute any directives, any macros, and delete comments. And the output will be .ii. So we have this main.cpp here. This is the command for invoking preprocessor. We say main.cpp. If I press enter, it won't generate a main.ii for us. It will only print it on console. Let me show you. As you can see, it printed on console. It also generated error code, said include mass.h, invalid preprocessing directive include. It proves that preprocessor also have its own debugging tools. Let's just fix it quickly. Save it and run it again. Yes, doesn't generate any error. So let's just create a file and write it inside that file main.ii. We are going to use it later. Here is the file main.ii. I type Notepad++ to take a look at that main.ii to see if those functionalities applied here or not. So here are some directives. b.h included. Here is mask.h also included. That comment, let me show you. Here we have a comment, as you can see, it also deleted, but it's still in a lexical format. It's not in other formats like, I don't know, machine code or assembly code. It's again a text file that just have some more directive instructions, you can say that. Let's just continue. The next step is calling or invoking compiler, and compiler is going to generate an assembly code with .s extension this time. And we know that each CPU has its own instruction set, so its own assembly language. We expect in this step compiler generate some error codes for us. Let's just take a look. G++, here we need to call s for compiler, and we say main.ii. So we should receive those two errors related to y and forgetting to include cstdio. Yes, we received an error. Oh, it seems more than an error. Printf, as we expected, was not declared in this scope. The other one should be y. Yes, it's also said you can find it on cstdio. We also receive for y. Maybe this is the same for y, because it said you forgot to use semicolon and in std use comma. Okay. Main.cpp, let's open it. Yes, we forgot also here to have a semicolon at the end. Okay, I'm going to quickly do the same steps because I want to show you that we also receive error for y. So let me just quickly type all of those commands. First for preprocessor, next for compiler, and cstdio, printf for cstdio. So it seems resolving namespaces is not the task of compiler, so it should be task of linker, because here we have an error. So let's just continue. I'm going to include that cstdio, include cstdio, and compiler not anymore should generate any error. And we should wait for this error in linking step. Let's see what will happen. I'm going to save it and type all of those steps again. Okay, we don't have that error. Preprocessor step successfully finished. Compiler step finished. We should have that .s or assembly file. Let's see. Main.s. Yes, we have that assembly file. Let's take a look at this assembly file. Main.s. Yes, this is main.cpp file that converted to assembly code. I'm not going to talk about the syntaxes inside this assembly. It's not related to this video. So this step also finished, but we know that we should receive an error in later steps. What will be the next step? So compiler generated an assembly code for us, as we said is CPU dependent, and the next step is assembler. Assembler is going to take this assembly code and generate a machine code for us, which is also an object file with .o extension. It's going to be replaceable or portable, but it's still not executable because that's the job of the linker. Let's just take a look. We say again G++, this time with C-C, this is the syntax, or this is the flag, and main.s. I don't think we receive error with assembler. You know, we are right now in assembler. I don't think assembler is responsible to find references. So I'm not expecting to receive any error in this step. Just press enter. Yes, as we expected, we didn't receive any error. And let's take a look at this machine code file. Let's just see the output is .o extension. The output has .o extension, and it's an object file which contains machine code. So let's take a look at it. main.o notepad++. Yes, it's in machine code, which is binary. Here in Notepad we are looking at it in hex, but it's actually in binary code, so the CPU can understand it, but operating system doesn't allow it to run it because it first needs to pass that linker step. Let's get back to this table here. We are in final step, the linker step, which takes object files, convert it to an executable file, which our system can be able to run it. But we know that there are some problems here. First of all, we don't have an object file from mass.cpp. The second problem is that y symbol that hasn't set its scope. The scope is mj. So we are going to receive these two errors. First of all, let's check the first error. So this is the command, and we say main.o and output it as main.exe. The first error is related to mass.cpp. Let's see. Yes, undefined reference to mj-foo, which is mass.cpp. And the second one, undefined reference to y, just as we expected. So we need to fix these two problems. First of all, let's just open that main.cpp file and fix it. The next one, save it. The next one is to have object file from mass.cpp, right? So let me just quickly do all of those steps for main.cpp first. Let me just clear the screen, and I think we have those commands here saved. And if I take a look, run the code again, I just only should receive error for mass.cpp for that foo function. Yes, I only receive error this time for that foo function. As you can see, we no longer receive error for a linker error, reference, undefined reference error for y, because now we define its scope. So just remember all of these steps, for example assembler, compiler, all of them also have their previous steps. So for example, if I call the assembler, it first called preprocessor, then called compiler, and at the end assembler. So we can directly say G++ C for assembler, mass.cpp and take a look. As you can see, we have this mass.o object file without the need to go through all of those steps from preprocessor to compiler and eventually assembler. Now we can link them together. Type g++ main.o mass.o and output them using linker. -o is for linker, called a file called main.exe. So let's take a look. Main.exe generated for us, and if I type main.exe, we have that output. Let's see. So we have y is equal to 5, and we have pi is equal to 3.40. if we add them together, because in site mass, the body of mass, we actually added them together, the return value is the sum of these two. And yes, 8.14 is what we expected, and yes, we have it here. So the video is actually finished here. In later videos I'm going to show you how to use other flags more related to error checking. We're also going to see what if our files are in different directories, are in different paths, and the most important thing is how to have dynamic and static link libraries and how to link them using G++ compiler. So these are the things that we are going to talk about them in a later video. Bye.